For section 2.3, we're going to talk about what they call measures of central tendency. And this usually has to do with averages. And so we'll have three different ways we talk about average. And that again kind of goes to where sort of a center point, kind of a central located point in the middle would be located. The first way we do this is by doing the mean. And so the mean is one way we often use in daily life for measuring the average. This example here shows the number of movies in different sci-fi franchises. A little bit out of date because it's as of 2012, but the idea for the mean is to add together the frequencies divided by the number of categories or values. So here they would add up 4 plus 7 plus 11 plus 6 plus 4 divided by the number of categories, which there are 5. And that gives us a mean of equal to 6.4. And if you visualize the data in its graph or bar graph or histogram, the mean kind of sits in the middle, somewhere where it is almost sort of balancing. If the data is sort of sitting on a scale, it sort of balances it in the middle somewhere. The other way of talking about average is through the median. To do the median, we have to first put the numbers in order, and then the median would be located in the middle of the numbers, or in some cases we have to take the middle two numbers, add them and divide by 2. But in this case, if we put the numbers in order 4, 4, 6, 7, 11, the median would be 6, which is the one number which sits in the middle. And like I mentioned, sometimes you have to go kind of halfway between the two middle numbers if there are two numbers in the middle. The other way of determining the average is through the mode. And the mode is just simply the most common value or groups of values. In this case, since the number 4 shows up more than once, and it's the only number that shows up more than once, it would be the mode. So the definitions of the three goes like this. The mean is what we most commonly call the average value, and it's found by taking the sum of values divided by the total number of values. The median is the middle value in the sorted data set, or halfway between the two middle values if the number of values is even. And then the mode is the most common value or groups of values in a data set. And so let's do that to this particular data set to find the mean, median, and mode. So to do the mean, we'll start by adding up all the numbers together, divided by the number of values that we have. There's a total of 8 here. So when we total up the numbers, it totals up to 11.28 divided by 8. And that's equal to 1.41 for our mean. To find the median, we need to first put the numbers in order. And then for the median, we're going to look in the middle and see if there's one number or more than one number. In this case, there are two numbers in the middle versus just one. So we have to find the halfway point between these two numbers. So to do the median here, we need to take the two numbers, add them together, and divide by 2. That comes out to be 2.74 divided by 2, and that's equal to 1.37. So that's our median for this particular set of numbers. And then lastly, the mode is the number that shows up the most. So if any number shows up more than once, we'll have a mode. In this case, we do. Notice how 1.29 shows up twice, and no other number shows up more than that, so our mode would be 1.29. Let's talk about, though, the appropriateness of our mean, median, and mode in different situations. For instance, think about the situation here where there are 5 graduating seniors on a men's college basketball team, and they receive the following first-year offers to play in the NBA, where 0 indicates that they did not receive an offer. So it looks like only 1 out of the 5 actually received an offer of $10 million to play in the NBA. The other 4 did not, so we put theirs in as 0. But let's think about, what does the average mean in this case? So for instance, if we take the mean it would mean to add them together and divide by 5, which if we do that, we get a number of 2 million. However, as we can see, that number from the mean is not really a good way of expressing the average of what the average of the players are receiving here. It looks like more or less most of them are getting 0, so on average we wouldn't really think of them getting 2 million each on average. So that number at the very end, the really big number, is what we would refer to as an outlier. That makes the mean unrepresentative of the data as a whole. So we have a definition for outlier, and the data set is a value that is much higher or much lower than almost all of the other values. And in general, the value of an outlier has little or no effect on either the median or the mode. Because if we go back to the example before, the mode and the median would both be 0, which is more representative of the numbers as a whole. Now, an important thing to discuss is the symbolic way we're going to represent things going forward. We're going to be moving into the situations where we need to have a identifier for population and sample, specifically when we talk about means and so forth. So we're going to start using the Greek letter mu to stand for population mean versus the letter x with a line across the top of it, usually referred to as x bar, for the sample mean. Because these are usually not going to be the same number, population and sample mean. And how we're going to represent them in this notation, we're going to start using the Greek letter sigma to represent the sum of the data values. So up on top, notice it has sigma x. That means to take the sum of all the numbers of the data values divided by either a capital N or a lowercase n. These represent respectively the number of entries in the population and the sample. So we'll come back around to this several times to talk about what these letters represent, but this is going to be the idea going forward. In a lot of cases, we're going to use some of these symbolisms to represent the different quantities involved. Let's look at another example. Here it says a track coach wants to determine an appropriate heart rate for her athletes during workouts. She chooses 5 of her best runners and asks them to wear heart rate monitors during a workout. In the middle of the workout, record these values: 130, 135, 140, 145, and 325. Which is a better measure of average in this case, the mean or the median? If we look at the numbers, and if we look at the median, we can see it's the number in the middle, so that would be 140. And if we were to calculate the mean, though, we'd find that it's 175 if we added the numbers together and divided by 5. So which one of these two is more representative, though, of the majority of the values? The issue here is there's a high value of 325. This is an outlier, which probably was a mistake when writing down the numbers, perhaps. We would hope so. So if we just took the numbers, though, on face value, the median of 140 appears to be a more reasonable value with less influence of the outlier to tell us overall kind of the general idea of what most of the numbers look like. There are other ways of calculating the mean, though, which add what they call weights to the calculation. So weights are a lot of times used in averages, especially when grades are involved. So for instance, if the final exam counts like 40% and the quizzes count 15%, this is going to be incorporating what they call weights into the average. So let's just, for example, throw out some numbers. Quiz grades of 75, 80, 84, and 88, and a final grade of 96. Doing the calculation with the weighted mean would look something like this. You're still adding things together, but on top you have to take each individual grade, like the 75, multiply it by 15, add it with 80 times 15, 84 times 15, and 88 times 15. Those are the percentages for 15. And then at the very end is the 96 grade times 40 for 40%, divided by the weights or the percentages all added up, 15 plus 15 added up together, all the 15s, and 40. So that comes out to be 8745 divided by 100, or 87.45, as what we'll call the weighted mean. So the definition here is that a weighted mean accounts for variations in the relative importance of data values. Each data value is assigned a weight, and the weighted mean is calculated by doing the sum of each data value times its weight divided by the sum of all of the weights. Or symbolically, we write it like this: x bar equal to sigma xw divided by sigma w, where w is the weight of each value x in the data set. And so what we're doing here is basically just expressing the fact that we're taking each weight given by w times the value x, multiplying them together, then adding them up together, divided by the sum of all the weights. In the case of a frequency distribution, the process is similar, but we'll just be dealing with the frequencies instead of weights. So in a frequency distribution, we take the sum of each data value times its frequency divided by the sum of all the frequencies. Symbolically, you'd write that as x bar equals sigma x times f divided by sigma f, where f is the weight of each entry value x in the data set. So let's take a look at the numbers again, and we're going to make sure to recognize that the first column represents the number of households with those particular numbers of children. So that's going to represent the frequencies, which we're going to let the letter F stand in for each of those. Each entry for each category here would be given by the letter X, so the 4, 2, and 3. Those are going to take the place of X when we do the calculations. So in the formula, we need to take the sum of each data value times its frequency. So we're going to do the data value 4 times the frequency 3, 3 times 4, 13 times 2, and 12 times 3. We're going to add those up together. We're going to take the sum of all of those to get a sum total of 74. And then we got to take the sum of all the frequencies. So the values 3, 13, and 12 get added together for a total of 28. So the mean from our table, our frequency table that is, x bar is going to be equal to 74 divided by 28, which is approximately 2.6. So up to this point, we've now looked at the shapes of graphs using things like bar graphs, histograms, and so forth. That can give us a sense of how the data is spread out and so forth. And they use the word distribution to describe this feature. So we look at the shape of the distribution to get an idea about what's happening with the data. And a lot of times we'll look at a curve approximating the shapes that we see. So here's some pictures of some histograms. And if we draw a curve that goes along the top of the bars, we get what's called the distribution of the data. It can even be for a line graph as well, but it's just a curve sort of approximating the basic shape. One way of describing the shape that we see in the distribution is by looking at the number of peaks. And the number of peaks is going to be equivalent to the number of modes as well. So we can have what's called a uniform distribution that has no mode. It's just a flat line distribution. If it has a single peak, then we call that unimodal. And if it has two peaks in the distribution, we call that bimodal. If it has three peaks, we call it trimodal. So the overall definitions here are is that a uniform distribution has no mode because all data values have the same frequency. A single peak or unimodal distribution has one mode because it has that one peak which stands out above all the others. And the bimodal distribution has two modes, two peaks. Trimodal, three modes or three peaks. Another word that's used to describe the distribution is symmetric. A distribution is symmetric if its left and right half are mirror images of each other, and they'll be cut down the middle, sliced down the middle in half by what's called the line of symmetry. Distributions that are not symmetric might go by two names, left skewed or right skewed. A distribution is called left skewed if its values are more spread out on the left side, and a distribution is right skewed if its values are more spread out on the right side. So taking a look at the pictures we have here, the left skewed, notice that the outliers, the tail of the graph, tails off to the left side. Therefore, they call it left skewed. Right skewed, the outliers are trailing off on the right side. That's why they call it right skewed. The outliers tend to pull the mean, in particular, toward that direction, toward the left or the right. So it skews our mean either to the left side for left skewed or right side for right skewed. But in the case of symmetric, both mode and the mean and the median will all be the same and be right in the middle. This last picture will have significance for us. This nice spread out symmetric curve that's unimodal with one mode in the middle will be called the bell curve.